I want to kick off the day by giving a brief overview of DeSci, starting with what really is this whole vision for decentralized science. Now, I have imposter syndrome to even feel qualified to give this talk, but DeSci Labs, however, described a really interesting vision of the Web3 of science back in April that I loved. They described this transition from the Web 2 of science. And it started with a problem that I commonly hear, which is that science is broken today because of the existing publishing infrastructure. Now, back at our DeSci Day at EthCC, Tomiwa Ademidun talked about the problems of this triple pay system, where scientists are basically doing free labor that's funded by governments, and then publishers like Elsevier are taking home 40% of the actual value being generated there. So the first step that I've seen decentralized science tackling is to fix this funding model. Organizations are rallying to promote healthier funding models for scientific research, for scientific publication, for IP ownership, for the business of science. And I think fixing value share is one of the best attributes of well-designed crypto tokens. Now, I'll note that designing a crypto token, well, isn't the easiest thing in the world, but at least there's a shot here. You know, a shot to go and design systems that spread the value, excuse me for a moment, spread the value back in favor of users, creators, and builders. And I'll note here in this model as well, you should also be respecting capital. I'm a capitalist, which is kind of a dirty thing to say in a DeSci crowd, but economics has funded the modern era. And without investors, things slow down tremendously. It's a lot harder to go and make change happen. Now, once funding has been resolved, let's go and fix governance, right? And reputation. I talked to academics and they feel trapped today, forced to either conform to the system or face exile. And DAOs have incredible potential to improve decision-making with radical democratization methodologies. New forms of governance, like, quadratic voting, are being rapidly experimented with. And look, we're early days. It's not all good so far. I'm in a lot of conversations where many DAOs are being panned as ineffective and failing. And yet at the same time, I see many more DAOs popping up. Oops. I got a fickly scroll wheel over here. I see lots of other DAOs that are being panned as ineffective as failing, but at the same time, I see many more DAOs popping up to try something a little different, to fix problems that they saw with the last model and do better next time. Now, to govern properly in a digital world, we need a way to know the identities of individuals and to establish reputation in a codified way, not with, deal making and special appointments. And I have very good news for you all. Web3 is based on security technology that can make this possible. Now, I won't get too technical here, but I will use a quick analogy to explain this. Now, please raise your hands if you are familiar with HTTPS. Yeah, this is a good crowd right here. All of you use HTTPS every day. It's that little lock icon in the top of your browser. This is 25-year-old technology that is currently on 95% of websites today. And it took 25 years to actually materialize. And it solved a very simple problem. I want to securely communicate with a website. To do this properly, it had to prevent somebody faking that they were docs.google.com when they weren't, and to prevent people from injecting fake information into our communications once I am sure that it's docs.google.com. Now, Web3 technology lets us have trusted transactions amongst many parties instead of just two. We can have a shared ledger of reputation data, for example, where we are sure that anybody who wrote to our ledger was permissioned to do so and is tracked in a way that can't be changed historically. Now, let's combine this with technology that's referred to as verifiable credentials. So, you should think of verifiable credentials similar to your driver's license. There was an issuer, the DMV. You hold it in your wallet, and you present it to a bar like Piano Fight, and they validate that it's authentic, and then you get to drink. The same thing is happening with that SSL certificate in your browser, right? This was issued by a certificate authority over here, and it's hosted by the website, and then you are the one that's actually validating that it's authentic. And I propose that the exact same pattern is going to happen with pretty much every credential you can imagine in the future. Your license as having been an alumni from a specific college, or being part of a hospital network, or part of a technology group. And this is a great thing. This is technological infrastructure that's enabling companies like decentralized.science to go and bring back control to the academic community and to do better peer reviews. And I know teams like DeSci Labs are working hard on this problem as well. Me, I'm a data nerd. So my focus at Weavechain is on how we can have a better transfer of bits between parties, the flow of data itself. Now, for DeSci Labs, they recently launched a product called DeSci Nodes that's beautiful. The concept is that today, people just publish these PDFs where you can't validate any of the information that's inside of them. Instead, they built a plugin that's attached to these PDFs that has verifiable metadata that shows, where's the source data that was used for this study? How was the paper reviewed? And how was that review verified? Is there actually reproducibility built into this research? And all this is done on IPFS, which is an incredible decentralized database for open science. I think that Web3 data is revolutionary. Again, it's rooted in security technology, and it creates a world where users can own their own data. They'll have these cryptographic guarantees that their data hasn't been tampered with, and that they know who's using it and how. And I think the hope for a lot of users is that they'll actually be able to derive more value from their data by being compensated with tokens directly for that data, as opposed to just getting a promise that a service is going to run a little bit more effectively. And, ideally be able to use privacy-preserving technology so that they're not being exposed to the world, and use it in these really interesting dApps that are coming along. But we saw a problem at Weavechain, which was that, like public Web3, we think is best for public goods, right? Technology that we really respect, like IPFS, is tricky because everybody has a copy of this data, and you don't have the ability to satisfy, GDPR's erasure obligations, right? For data to be GDPR compliant, you have to have the right to be forgotten. And on a service like Arweave, for example, the permaweb, you can't delete data by default. This data is also not HIPAA compliant. For data to be HIPAA compliant, you can't just have technical safeguards like encryption. You also need to have physical safeguards, things like firewalls, and making sure that only certain machines can actually access that data. And I believe that these regulations exist to protect us, the users. I've signed on to the My Data Consortium, which is an organization that's pioneering thought leadership in this complex space to figure out the right way to treat data to be in the benefit of users. So our solution at Weavechain is to add Web3 benefits on top of a normal compliant infrastructure that many of us are used to today. So an application stack running in an AWS with some databases and a compute engine. Our nodes are deployed on premise right into customer environments, connecting to data either via an API or by listening to any database from MySQL to Mongo. And then, our trick is that we're only going to put a one-way hash of the data on chain to give it those really nice Web3 security benefits, but keep the data off chain to go and maintain GDPR and HIPAA compliance and give maximum flexibility to data owners. Then we act as the gateway for all data transactions by letting people run API calls to our nodes so that you can do things like compensate people with tokens for data. Now, I think if we've solved all of those challenges listed previously, that the last exciting bit of DeSci is really going and trying to incentivize more grassroots activity. And, Tomiwa said it great this summer. DeSci makes it easy for anyone to contribute to science. And I'm excited to say that it's not just a blind anybody. DEI is top of mind for almost every one of the practitioners of DeSci that I talked to. Paige from the Women of DeSci told me this summer that diversity, equity, and inclusion is real, important, and necessary, and we agree. Over half of our long-form talks today are from female speakers. Genuinely just because so many of them were putting forward such awesome proposals. And, I hope that I'm representing my Egyptian and Mexican heritage today here as well. But it's really exciting to see that, decentralized researchers are achieving incredible things right now. This summer, a decentralized science project contributed to a COVID vaccine that doesn't require deep freezing. This is really incredible stuff. But even before scientists and thought leaders, I see companies trying to incentivize the average person to do more for science. Dr. Kyle Bergquist is a pain relief specialist from Northwest, and he founded a company called Reputable Health that's trying to build a better model for science using Web3 technology. So he's connected with researchers that are hungry for as much patient data as they can get their hands on, whether it's from your wearable heart rate and sleep data or your glucose monitors. And his concept is to go and see if he can incentivize users to share their data by giving them tokens for that data and guaranteeing them that their privacy will be preserved. So he's working to build out this Web3 wellness data economy that I think is really fascinating. And there's a lot of other companies that are doing similar things out there. We were chatting outside about Voluntas earlier and Data Lake. And if this model comes to fruition, you're going to have so much more data available for science than you ever have before. Now, I wanted to show you a little bit about this privacy-preserving technology. Let's take a quick poll again. How many of you have heard of confidential computing? Just quick raise of hands. Awesome. Not zero, but not quite as many as our HTTPS analogy. So the idea with confidential computing, it's similar to sort of what you hear with zero knowledge proof sometimes. It's this idea, how can I go and run research against a data set that I can't see? So let's say that we have a hospital that has a ton of patient data on its servers that it just can't share in a raw format with researchers. In a compute to data scenario, we're going to say, okay, researchers, I'm going to go and give you a schema of that data. You go and design your analytical process, and then we'll run your process on our servers against the data and just give you the results, but never show you the raw data itself. We love this model. There are a variety of different forms of confidential computing. We support compute to data Weavechain, as well as federated learning, multi-party computing, homomorphic encryption. And one of the really cool things here is that you add Web3 security to this process, in our situation, by going and hashing the data that's being used to the blockchain, the compute engine that's being run, and the results themselves, and having each one of the nodes involved in the system actually sign that they performed this calculation. And we're looking at a one-to-one scenario over here, but we can do this against multiple sources as well. If you've gone and designed this research process, why not go and suck up data from every single source that you can get access to? Let multiple hospitals contribute their data without necessarily sharing it with each other. Let data exist on end user devices without ever moving to a centralized location, but still be accessible for research. So these are pretty abstract concepts. So I wanted to actually show you a quick demo of how we do this using Weavechain technology. So let's say that we have an interesting producer of data, Acme Medical. We're going to go and set up a Weave, which is our branded term for data that's tied to a blockchain. They'll go and attach their existing oncology patient database to it, share it with a consumer, Oncotech, who will go and connect to that Weave, pay some USDC to replicate raw data to its servers, pay some USDC to run confidential computing, and then analyze all the hashes, signatures, and some ZK proofs that were generated to go and give this data really nice Web3 properties. So let's see how good I am at doing a one-handed demo while holding a microphone. I'm going to start by launching a Weavechain environment over here, and I'll create a new account, which in Web3 terms is really just a public-private key pair. Let's say this locally. And this will be for Acme Medical. Then we'll create a Weave. And for our product, the first step is actually launching your node, which we'll be doing in Docker. The second step is saying, I want to go and put this oncology data on a specific blockchain. And we support a variety of different blockchains to store your hashes. We're doing our own layer 1 that's optimized for big data. And then now I have my Weavechain node running. So we finished our setup. Now let's go and attach a database. Here, we're letting users operate with whatever database format they're comfortable with. We're just entering the connection string over here. And then we see that our database has a directory of hospitals and some patient data. Now, this is a critical step. We don't want anybody to be able to access this patient data in its raw format, only with confidential computing. Then we'll go and establish some fees for this data and say, all right, researchers, you can go and run computation for 100 USDC per day, or you can go and access our directory of hospitals for 10 USDC per 100 records. Now, the last step over here is we need to say who can actually run these processes. We're doing this with fully role-based access control. We think this is the only way you can really do things for really sensitive data sets. So I'm going to go and log in with my user from Oncotech. And he'll copy his public key and say Acme is going to let Oncotech read data and run confidential computing. We'll copy the node address from Acme, and then Oncotech will say, I'm going to go and join that weave. Now, let's have Oncotech pay some tokens to go and replicate raw data. So here we have the Oncotech environment, and let's say to sync this data into Oncotech's local database, it's the same situation. He's entering his database credentials, but now he's got to go and pay some tokens to access the data. And once he does that, he can see this directory of hospitals, but he cannot see any of our patient data. All he can see are the field names. And this is the part that I think is really exciting, is let's go and make it so that we can run some research against that data without ever having seen it. So our Jupyter environment is just running some code over here where I'll connect to the Weavechain node. I can read from that directory of hospitals the same way I could from our UI. But I can't read the patient data, right? I'm not authorized to do so. What I can do, however, is run a linear regression or understand the correlation between smoking and severity of cancer just by knowing these field names. Right? I'm running this research the exact same way I would locally, but I've never seen the patient data. And this can get as complex as you want. I could go and train a machine learning model on this data set using that compute to data technology I mentioned earlier. So here I have all my Docker containers. And when I run this bit, it's actually going to go and spin up a Docker container in the background over here to train this machine learning model. Now, my computer's running a little slow today, so I'll do a quick bit of movie magic and just show you what this model looks like once it's generated. And the great thing over here is that, I can go and use this model on the data to understand, the importance of things like alcohol use on severity of cancer without ever having seen the data itself. And like I mentioned earlier, we're going and creating hashes of every bit that's happening over here. The inputs, the computation engine, the output, and signing it by the node that actually performed this calculation. Now, another slow bit over here, we enable zero-knowledge proofs on that data as well, so that I could go and debug the patient data by ensuring that none of my patients has an age that equals 0 using zero-knowledge proofs. And the end result for Acme Medical, again, is just that they have securely enabled access to their data and earned some USDC from a consumer that ran some research on their product. Now, I appreciate you all bearing with me as I ran a pretty technical demo over here, but this stuff is important. I think we all need to be worried about privacy immediately, because really technology is only moving in one direction. I was watching QuarterCon a few weeks back, and Vodafone was talking about how they're working to go and create not just the Internet of Things, but the economy of things. They see a world where every device is connected to every other device and sharing data in real time in a transacted way. And, if this is done wrong, it's dystopian. If it's done right, it's in fact more secure and creates more privacy than you have today when you're using technology like confidential computing that I mentioned earlier. Again, though, this can be some creepy stuff if not done right. This is why we're really excited when we're doing our work with companies like Mama Root that are working to use IoT beacons that understand human movement patterns in the real world. They're running a pilot in Japan where you literally earn tokens for exploring a store or a shopping mall. Without that store or shopping mall, being able to understand where you personally are going during the day. They're going to make it so you earn NFTs for exploring different parts, like visiting locations in a Zelda game. I love these ideas. They're really exciting, but they need to be done thoughtfully and done correctly. And it's not just, location data or medical data. We're working with another company called ClimateCheck that's going and trying to incentivize the collection of data that will help in tackling climate change. They're a Nigerian company that's selling users a little box that you can put in your house that will be collecting air quality data that they then sell back to refineries in the area that are trying to conform with ESG standards. The idea is simple here. If you're an end user, you buy one of these boxes, you plug it in, it pays itself off in 6 months, and then it's just a recurring stream of revenue for you in the future. And you're going and helping the world while you do it. This is a complex map. I'm not going to go here and say that decentralized science is simple, but there are different people that are working on every part of this problem. This is what the DeSci landscape looked like in February this year. There were 47 organizations tackling different pieces of that problem. And here, less than a year later, we've increased that number by almost 3 times. Raise your hand if you're here today and you're part of this landscape. Any other of the, there we go. I know lots of people are part of this conversation and excited to go and be a part of this tribe that has this awesome vision. Because we all want these things, right? We want to go and fix the funding model for science. We want to fix how governance happens and fix reputation identity and have data moving, more securely between parties and incentivizing more people to participate in science. And I'll close today with one last note that, from where I'm sitting, I see academia and industry wanting to help with this evolution. It's sort of easy to say we're going to go in and, recreate everything and do it better this time. But I think there's a really interesting opportunity here to partner with the institutions that already care about this and have set up an incredible infrastructure to do so. Just 3 weeks ago, I was at the North America Blockchain Expo, chatting with the blockchain teams at Pfizer and Johnson & Johnson, who are super interested in decentralized science. They're part of consortia like Melody and PharmaLedger, who are doing really challenging things from a legal perspective, like nailing electronic consent to go and participate in a decentralized clinical trial. And academic institutions like Stanford and Berkeley are bringing brilliant minds to bear to support our efforts. And I think we're all stronger when we work together. And if we do, nothing's impossible.